If you're watching this video, then I assume you already know about Airflow as well as Kubernetes. If not, I would highly recommend you to watch my tutorial videos on Airflow. The link is in the top right corner as well as in the description below. And for Kubernetes, I haven't started the tutorials yet, but I am going to very soon. You just have to get basic understanding of Kubernetes. You don't have to worry about how to set up, because in this tutorial, we are going to show you exactly that. There are a lot of resources and tutorials online. Their official documentation is also very helpful. Video's outlines include: first, we'll give you a quick recap on Airflow Kubernetes Executor based on our previous video. Then we are going to look at an overview of how Kubernetes manages and runs Airflow workflow inside the cluster. Then time to get some hands dirty on spinning this multi-node cluster on your local machine using kind. Once we have that up and running, then we will gonna prepare our Airflow Docker image and push it to our local Docker registry. Then we are going to go ahead and create a very minimal Helm chart, and then finally deploying Airflow on Kubernetes using Kubernetes Executor. So let's get started. Just another request before we get started is, if you are watching and liking our content, I would highly recommend you to please subscribe our channel, as this is going to keep us motivated to bring such useful stuff to you guys in the future. As I can see from our channel stats that only 2% of the viewers are our subscribers, whereas the remaining 97% of them are non-subscribers, which does not look good at all. So if you think our content is useful to you guys, please subscribe and share it with others, and also let us know your thoughts in the comments down below. We have already seen what advantages Airflow provides when it runs on Kubernetes using Kubernetes Executor in our previous video. If you have missed it, I would highly recommend you to watch that. The link is at the top right corner, where we talked about the advantages that it can scale down to 0 when there is no task to be executed. We don't have any additional worker nodes to run. It is fault tolerant because of the nature of how Kubernetes manages these pods. Whenever it fails, it automatically spins up the new pod and maintains the desired replica of that pod within the cluster. We can assign customized resources to the individual tasks, and because of all of that, it is cost and resource efficient. And speaking of the cons, in which the major one is, of course, you have to know about Kubernetes and how it works. And the second drawback, which is like really minor, is about a slight delay because Airflow spins up a separate pod for each task. Now let us go ahead and look from the Kubernetes perspective of how it manages to run Airflow within the cluster. So as I said, we are going to spin up a multi-node Kubernetes cluster within our local machine, and that we will be able to do this with this tool called kind. I have a separate video on this, how you can spin up a multi-node cluster using kind. The link is again in the top right corner. So what kind does is, within your local machine, it actually spins up multiple Docker containers, and each of the Docker container works as a Kubernetes node, out of which the first one acts as the master node and all of the rest works as the worker nodes. The master node actually runs the Kubernetes control panel, which actually controls the entire cluster. A cluster should always have at least one master node. There can be 2 or more as well for redundancy. Components of the master nodes includes API server, database for holding the state of the cluster, control manager, scheduler, etc. We are not going to the details of that because that's not the scope of this video, but consider this as all of the control panel components that are required to run and manage the cluster. Whereas worker nodes are the nodes on which you can run containerized workloads. Each node runs a kubelet, which is an agent that enables the Kubernetes control panel to control this specific worker node. These worker nodes are used by the organizations to run a variety of workload business logics. As an example, in this case, if you're running Airflow, our scheduler, web server, and MySQL are going to spin up in the worker node. And then whenever there is a time to trigger a DAG, the DAG's task is going to spin up within the same node as a separate pod. Then as an example, we have another task for the same DAG, and when the task finishes, the pods disappears. And similarly, these DAG's tasks appear and disappear based on their scheduled timings. And similarly, if you have more than one worker node, then Kubernetes is going to make sure that the load is equally shared between each node. In a scenario where, let's say, you have more than one schedulers configured for your Airflow, then maybe the first worker node would have sufficient enough memory to run this Airflow core components like web server, multi-schedulers, and then the SQL And in that case, all of your business logic DAG tasks are going to be spinned up on the rest of the available worker nodes by the Kubernetes. And the way how it actually works is, the Airflow Kubernetes Executor, which is running inside the scheduler, actually sends an API call to one of the API server running in master node to spin up a pod. And then the master node decides on which worker node I need to spin up this pod. In this case, the available worker node 2. And that is the beauty of running Airflow on Kubernetes, because we don't have to worry about the load distribution or fault tolerance, because if any pod fails, Kubernetes is going to spin up another pod in its replacement. And it is going to do so until the pod has finished its task or it is being terminated with error. And then it is going to report back the status of that pod to the Airflow, which we will be able to view as the DAG task states in the web UI, which we are going to look at how it works once we have set it up the DAG. So that's all what will be happening inside the cluster. From the outside, we would have like two more main components. The first one is the helm chart. This is nothing but just a bunch of YAML files that defines the deployment manifest of these Kubernetes, like the deployment YAML file for webserver, for scheduler, for MySQL, etc. We are going to look at that very shortly. The next bit is, of course, the Dockerfile, in which we are going to bake in our dags and deploy it in our local Docker registry, which will be used from our Kubernetes cluster. You're going to get this repository as part of this tutorial, in which I have set it up everything you need to spin up Airflow on Kubernetes. So it has 3 main directories in here. So let us go through each of them one by one. So the first one is the kind cluster. In here, we are going to use this tool called kind Kubernetes in Docker that is going to spin up a multi-node Kubernetes cluster within our local machine. I have a separate video on this, so you can follow up the link on the description. But just to give you a quick recap, so this script is actually taken from their official docs with some slight modifications. So what this bash script does is actually spins up our local Docker registry at localhost 5001, where we are going to push the Airflow image, and the pods running inside the cluster are going to pull the image from this local Docker registry. And then finally, we have our kind config file defined in here, in which the first one is the main master node called control plane. And then we have one worker node with some required labelings. And we are also attaching an extra amount where we are going to store the logs of Airflow. So this is going to make sense once we have Airflow set it up and running. So don't worry about this if you're not following completely, but you just need to get a high level of overview of what's actually happening. And then we are telling our cluster to use this local Docker registry from where to pull the images. For that, we have to define the config maps as well. So that is pretty much it. And let us spin up this multi-node Kubernetes cluster on a local machine. So for that, you just need to run this bash script. So let's cd into kind cluster and say create cluster with registry. If you look at our Docker, it has created this registry container and one master node and one worker node. And now it's configuring both workers in order to form a Kubernetes cluster. All right, looks good. So we have our Kubernetes cluster up and running with 2 nodes, as you can see, and 1 Docker registry. You can go ahead, try accessing this cluster. For that, you need to have this command line tool of Kubernetes called kubectl. And you just type in kubectl config get contexts. So this is going to give you the list of all the available Kubernetes clusters contexts that you have configured in your local machine. And the one that we spinned up just now is mentioned in here, kind, which is not a perfect name, but should do for this tutorial. The little star in here mentions that this is the cluster which is currently being used. If this desired cluster is not selected, then for that you can type in the command called kubectl config use context, then the name of your cluster. So it has switched to kind, which it already was. So now we are going to use another tool, which is going to give us a command line user interface to access the resources of the Kubernetes, which is called k8s. So as you can see, we are inside our kind cluster and we are looking at the default namespace with current pod. As you can see, we have none right now. But if we look at all the available namespaces, we can see all of the namespaces which are part of the master node. Nice. So we have multi-node Kubernetes cluster running on our local machine. All looks good. Now let us go ahead and build our Airflow image. For that, we are referring to this Airflow dags directory. In here, we have simple dag directory in here with a very simple hello world first dag, which just prints hello world from first Airflow dag. Nothing special in here. Then we have a Dockerfile that uses Airflow version 2.3.3 with some optional tags in here. Then using root user, we are installing some required tools needed to run Airflow with Kubernetes using MySQL database as the main database for storing Airflow metadata. Once all installed, we switch back to the Airflow user. And as a last step, we simply copy the dags mentioned in this dag directory into the Airflow home directory. That's it, pretty much simple Docker file for our Airflow. Let us build this file. So first go back to our desired directory, Airflow dags, docker build, and let's tag this image as Airflow first dag. Let's give it a version of 0.10. All right, our image is ready, which is tagged as following. Now, in order to push this into our local Docker registry, we have to make a copy of the same image with a different tag. So we say docker tag, take this image, and we're going to say localhost 5001 Airflow first tag 0.10. And we're doing this because this is the address of our local Docker registry. Now, if we copy this and say docker push, so as you can see, this is being pushed into our local Docker registry. You can see the logs of the local Docker registry container. It's receiving this image. It's going to take a bit of time. All right, all good. We have successfully pushed the Airflow image in our local Docker registry, which should be readily available to be picked up by our local Kubernetes cluster. Now let us go ahead to the last part of this deployment, which is deploying our Airflow on Kubernetes. For that, we are using this Helm chart. For those of you who are not familiar with Helm chart, it's nothing but just a bunch of some YAML files which are defining the resources to be deployed into our Kubernetes. You'll get to know more in just a bit. So if you look at the templates file in here, we have the directory called deployment. And in this, we have three core components required to run Airflow: the web server, the scheduler, and the MySQL database. And these are simple YAML files that are representing the deployment of Kubernetes. If you look for a MySQL, we start with the deployment, and the main bits to focus in here are under spec, we have the definition called containers, in which we can define multiple containers. But for this one, we are just using one single container. So the image we are using is MySQL 5.7, and the container name is MySQL app on port 3306. And we are passing some environment variables in here, mentioning the database, user, root password, and the password. So these curly bracket things you're seeing here are actually the Jinja templates, which is actually the core part of this Helm chart. So what this refers to is actually values MySQL database. So if we control click this, it is going to take us directly to this values.yaml file. In this, we are defining all of our values in here, and that's what we call it as a chart, where we can define all of our required variables in one place and use them within our YAML files where needed. So as an example, in MySQL, we are using this host value as MySQL. So if you right click on this, it is going to show you all of the usages in here. So it's telling that it's used in MySQL.yaml, metadata on the name. And similarly, the database is used over here. And rest of these variables, we are actually fetching them from the secrets. Secrets is another resource in Kubernetes, in where, as the name says, we store all of our secrets. So in secrets, I have created a separate YAML file, MySQL, which defines the username and password. And this password is actually being taken from the values as well as the username. So if we click here, we are going to be redirected to the values that we have defined in our Helm chart. Oh, by the way, if you're wondering how I can select and choose back and forth on these values, it's actually a plugin that I have installed in my PyCharm. So if you go to preferences and you need to get these two plugins, Go template and Kubernetes template, in order to get this feature. In fact, it automatically identifies all of these values defined in our chart. So if you say values, you're going to get MySQL, and in MySQL you have all of these available values that you have defined in your values.yaml file. And since these are secrets, so that's why we are going to encrypt it while stored in the Kubernetes. And similarly, we have Airflow secrets where we are defining the fernet key, as well as in the web server secret, we have username, password for the user, which is going to log in, as well as the web server secret key as well. So once we define this deployment, so this is going to spin up a pod with single container in it with MySQL app. And then we are defining the service, which is going to make this pod available to be reachable to the other pods with the auto-resolve DNS name by the name of the service itself, which in this case is MySQL. So this is all going to be very confusing, I'm telling you again, if you are not familiar with Kubernetes. And then we define the scheduler deployment, naming it as Airflow scheduler with a couple of init containers. So as you know, init containers are actually the containers that initializes before actually starting the main container. So in this case, what we are going to do is actually initialize init container to wait for the MySQL and make sure it's running. So it is going to loop until the MySQL host is available. Else it is going to keep on waiting and check every 2 seconds. Once MySQL is ready, Airflow is going to initialize the database in the second init container known as run Airflow migration. So here we are saying Airflow DB init and Airflow DB upgrade. And in here, we are actually passing some important environment variables required for the Airflow to run. The main one defined in here is the connection parameter for the database itself. Finally, when the database migration is completed, we are next going to create an admin user. So this is another init container, create admin user with command as Airflow users create. The role is admin, the username is admin, the password is, we are actually taking it from the values. Actually, as a matter of fact, this should also be taken from the secrets. So I think I already have that, yes. In here, we are going to attach several mounts. So the first one is the Airflow configs, which is attached as a volume that is taken from the config map. So Airflow configs. So this is all of our configuration file required by the Airflow. As you can see, the executor is set it up to be Kubernetes Executor, dags folder, opt Airflow dags, and all of the required parameters to run Airflow on Kubernetes. Then we have a separate volume for pod templates, which is also a config map taken from here. Because this Kubernetes Executor is actually going to spin up another Kubernetes pod. Airflow provides this nice option to us to provide what a pod definition should look like when the Kubernetes spins up this worker pod for us. And finally, Airflow logs volume, which is a persistent volume claim, which we are defining in the volumes, persistent volume as Airflow logs on the host path as temp data. This is the host part located in the worker node. Remember when we were defining the worker node, we attached an extra volume here. Host path is data and container path is temp data. So as we spin up this container, we can see this directory in here called data. So all of our Airflow logs are going to be persisted here. We are going to see that once we have pods and workers running in Airflow. We attach these volumes with the Airflow scheduler, web server, as well as the worker pods which are going to run. And web server definition is pretty much similar to the scheduler. We have this deployment in here. We have init container which waits for the MySQL to get ready. And then we have the main container which actually runs the Airflow web server with all the required environment variables and all of the volumes required. This is a web application, so it does needs a service that is going to provide this pod an IP address where we can access and view the Airflow dashboard. The container port is 80 and the output exposing port is the 8080. And that is pretty much it. We have covered almost all of the resources defined inside this template file. I think except one, which is the role-based access control, because of the fact that our scheduler hits the Kubernetes API to run the pods. So we want to create a separate role for Airflow and grant the permissions to allow spinning up the pods, deleting the pods, and all of the required activities needed to manage the Airflow scheduler to perform all of the activities required with the Kubernetes pods as part of the Kubernetes Executor. So in this case, we are giving the permissions on resources pods, pods logs, and pods exec on actions like watch, create, delete, get, list, and patch. And then we finally bind this role with the service account. So that is all, I guess. Now I think it's time to run and deploy all of these resources in our Kubernetes cluster and see Airflow in action. For that, we are going to use this helm command. First, let's go to the desired directory, helm charts, and we're gonna say helm upgrade install. Here you provide the name of the chart. In our case, we say Airflow, and the namespace in our case, let's say we are going to deploy this in default namespace. Then you provide the values. So in this case, we are providing this values.yaml file. Make sure that the image here is actually the correct one that you recently built and pushed to local Docker registry. I think this is not the one. So it was Airflow first tag 010. And now let us go ahead and run helm upgrade install Airflow. As you can see, it successfully deployed this whole chart in here. Now go back to our cluster, and if we switch to the available pods, so in k8s you say shift semicolon pods. So we are getting some errors in here. For MySQL, it says unable to pull the image pull error. So you press D to define the events available in this pod. All right, it looks like it's not able to fetch this image from public Docker Hub. I think I have this image locally in here. So if I say Docker images, I have localhost 5001 5.7. Yep. So if I push this image to local Docker registry 5.7, I mentioned this image in the deployments MySQL in here. All right, and I simply run this helm upgrade command again. It is going to redeploy this chart, and nice. So it was successfully able to pull this image MySQL, which is looking all good. But we have few issues in Airflow web server and scheduler. Invalid image name. Right. Okay. So if you press D to get the details. Oh, got it. So I think I found the issue. So the image how I'm referring to in the helm chart is wrong. So if you go to values, so this part should be in the tag. So that should do. All right, yeah, it looks like it's running, and this init container is waiting for the MySQL to be available. As you can see, the MySQL server is already available, but it sometimes takes a bit of time to identify this, as the DNS service in Kubernetes cluster sometimes gets slower. So this may take a bit of time. Looks like our web server has started before scheduler, and in this case, it is going to give error. Because it says that the database has not initialized yet, and which is true because this database initialization stuff is actually going to happen in the scheduler pod. As you can see, it's happening right now. Yeah, that's been completed, and now it's creating the admin user for us. Completed, and now it is going to spin up the Airflow scheduler. All right, it looks like, yeah, it's running fine so far. And now the web server should also be happy. Yep, looks good. Nice. All right, so now it's time to access the web server. We can do that by simply port forwarding our web server port. So you say Shift F. It asks for on which port. So 8080 localhost should be fine. All right, so now if you go to our browser and type in localhost 8080. Nice, so we can view this Airflow web server dashboard. So that's 1, 2, 3, 4, 5, 6, 7, 8 and admin. So if I sign in, and we can see our first Hello World tag in Airflow running on multinode Kubernetes cluster. So all looks good. We can trigger this tag and see it running in our Kubernetes cluster. So this is the pod. Oh, it actually ran and just disappeared because we were literally doing nothing in there except printing the statement for hello world. So yeah, it should be visible in here as well. If we press auto refresh. All right, so this is the first execution ran. So if we click this and click log, we can see the logs of the DAG, which is hello world from first Airflow DAG, which was literally what we displayed in this tag. Let me trigger this one more time manually and give you an actual view of how it's running in the Kubernetes. So as you can see, it's running on a separate pod, which means that we are not using any resource of either the scheduler or web server. In fact, what happens at the back of the scene is actually the scheduler, which is configured to use the Kubernetes Executor, actually hits the API of Kubernetes to request for spinning up a separate pod for us, in which the business logic which is being mentioned in this tag is executed. So imagine if you have auto scaling enabled in your Kubernetes cluster. Imagine if you have hundreds of tags in which you have like 50 tasks running in each of the tag. If all of your Kubernetes worker nodes are utilizing at their full capacity, the Kubernetes autoscaler is going to spin up more worker nodes for you and make sure that all of these DAGs run without any failure. You can also configure your Airflow to set like how many DAGs at a time should run and also how many tasks in parallel should run for each tag. So those kind of configurations and a lot of other fun stuff is going to be part of our upcoming videos. So stay tuned guys, and I hope this was helpful to you guys, and if it was, please don't forget to like, share, and if you are new to this channel, please don't forget to subscribe. This is going to keep us motivated to bring such useful stuff to you guys in the future. So I will see you in the next video. Take care. Bye.